The only planet orbiting the Sun that has continents, oceans, plate tectonics, and the sole planet with an atmosphere that has sustained life for billions of years. How did Earth get this way? What's behind the power, the violence that cracks solid rock in an instant, that shatters buildings and sends tsunamis racing for the shore, that erupts seas of lava and billowing clouds of ash? Earth has been making headlines lately.
Powerful images of destruction never seen in our lifetime.
People are asking, has Earth entered a period of intense geologic upheaval? Scientists have new answers to questions about our home, the third planet from the Sun. It's a story that just a few decades ago could not have been told. About 10 billion years after the Big Bang created the universe, our solar system began to form. Scientists calculate that this happened 4.567 billion years ago. And that was when planet Earth was created.
A long time ago, about 4.5 billion years ago, the Earth formed from this nebula around the sun in the center, and this nebula swirling around, and the bits of the nebula accreting, that is sticking together and colliding with each other. And it was a very turbulent time. And the Earth gradually came together, and as it became more massive, the gravitational force became larger, and it could attract more of these small pieces. And the Earth grew and grew.
It took about 100 million years for Earth to reach its present size. But before it did, our planet experienced its largest, most dramatic event.
So after the early Earth formed, probably tens of millions of years afterwards, you had a Mars-sized object that actually hit the Earth.
The giant planetoid impactor was called Theia.
The Mars-sized impactor hit the Earth, and it spewed off a lot of the material from the Earth, and part of that formed the moon that we now have. And also we generated a lot of heat from this impact, and so it might have remelted a lot of the early Earth.
Scientists only recently learned of this massive impact by studying rocks collected on the moon. It turned out that the moon rocks were very similar in composition to Earth rocks. After the impact, the moon became a satellite, while the Earth was left a molten ball of fire.
And so the early Earth was like this molten mass that must have looked like maybe one giant volcano or lava lake. It slowly solidified and formed this outer crust that is where we stand today.
As the crust formed, collisions and bombardments died down, but the meteorites continue to fall to this day.
We start with some breaking news this hour. People in the Urals in Russia have seen burning objects raining down from the sky after a meteorite exploded above the Earth, causing a meteor shower. Eyewitnesses reported several blasts.
Despite the shock that a meteor shower can cause, meteorites are extremely valuable to scientists who study when the Earth was created. They are collected and studied worldwide. But the best place to find these rocky aliens is one of the Earth's most unearthly places: Antarctica. On the sleek blue ice expanse of the central Antarctic ice sheet, the surface is swept clean by relentless winds. A meteorite sits exposed for an average of 20,000 years, sometimes for several million years, before scientists might spot it and collect it. A type of meteorite called a chondrite contains the same basic elements that make up the Sun and planets. So they tell us a great deal about where we originally came from and when.